just looking at arranging things in a line that have restrictions. So, for example, let's just look if we wanted to arrange 5 people in a line, but there's 2 particular people that need to be together. So let's just say need to be together. Let's just say that basically, let's say Reese and Ben need to sit together in this line. All right, so let's have a look at this. So if I had 5 people and we were looking at putting them in a line, that means you would have 5 choices like this. But what happens is if you put, say, Reese and Ben together, you treat them as one unit, okay? So let's just say they were like the 2 people and you hook their arms together. So there's Reese and there's Ben. You hook them together so that they're together. You treat them as one, okay? Now, you could have Reese Ben or you could have Ben Reese. So that gives 2 different possibilities because that's actually different if you swap them around and you interact the left elbow of Reese with the right elbow of Ben or the right elbow of Reese with the left elbow of Ben. Okay, so that can be done in 2 times 1 or 2 factorial ways. So if you treat them as one unit, then how many more people would you have left? So there were 5 people altogether. So there's 5 altogether. And then how many would you have left? That would mean you would have, so you got Reese, Ben, and then you would have 3 more. So that means that if you treat that as you got 1 person plus 3, that means there would be 4 people. So that means that could be done in 4 factorial ways because Reese and Ben are 1 people, and let's just say you have the other people, let's just say M, N, and Z, we'll call them. Then we have 1, 2, 3, 4. So that could be done in 4 factorial ways, and then times the 2 factorial because that will take into account whether you got Reese Ben or Ben Reese. Okay, all right. So let's just say we're going to arrange 5 people in a line and Amala, Elise and Rosie must be together. So if you put Amala, Elise and Rosie, you put them together as one group and you treat them as one. So they equal 1 person. Interact them with their elbows so they're all together, so they're connected. And then after that, if they're 1 person, then that means that you have 2 more people left. So if they're 1 person and then you've got these 2 people, then you will have 3 altogether. So that means that group will be arranged in 3 factorial lines. Because it's like getting, like there's 1 group, we'll make that person, this person here, and then the group of 3, like this, could be there. And then you still have this person here. That's another possibility. So you're just kind of moving these people, this group, along the line as one group. Okay, so there you go. There's another one. There's the group. And then you got the one with the funny hairdo could go there. And then you got that person. So it's still 3, but there's lots of different ways. So 3 factorial is 3 choices times 2 times 1, which is 6. But within themselves, like they could go Amala, Elise and Rosie, or you could go Rosie, Elise, Amala, or you could go Elise, Amala and Rosie. So there's even more ways than that, okay? Because here you could have Rosie, Elise with Amala. So if you have less here, then that would be 3 times 2 times 1. They could be done in 3 factorial within themselves. So there's 3 factorial, because that does how many within the group. So that would be just the group. That would be that 3 factorial. And then you do times 3 factorial because that's treating it as 1, 2, and them as the 3rd person. And that would be 6 times 6, which I think is 36. So that's just an example of 5 people in a line where you're having 3 of the people must be together. Now, what if I changed the putting together and I put not together? Okay, so I've got 2 people in a line of 8 people and 2 people